Good afternoon and welcome to OSU Extension's Agricultural Natural Resources Madness Tournament of Education. I'm Julie Strasser. I'm a program assistant with the department, and this is our way to bring programming to you since you can't come out to see us right now. So today we are going to stick with the sheep bracket, and if you missed it this morning, we had Christine Gelly, and she is our Agricultural Natural Resources Educator in Noble County, and Brady Campbell, who is our program coordinator for our sheep team. And they are here. We're going to talk about sheep nutrition today. So can Brady and Christine, can you hear me out there?
Yes, we can, Julie.
Yes, good here.
Awesome. Well, if you want to start sharing your screen and we'll get started.
Very good. Well, welcome back, guys, for those that were with us this morning, and welcome to you that are just joining us here this afternoon. Christine and I are excited to continue talking about sheep here for this afternoon. So, as Julie said, my name is Brady Campbell, Program Coordinator, OSU Sheep Team. I'm also a PhD candidate within the Department of Animal Sciences. And along with me today is Christine Gelly. She's the A&R agent, OSU Extension down in Noble County. So for the first portion of these slides, you'll hear from me. We'll kick it over to Christine, and then we'll wrap it back up with some stuff that I have to wrap us up with. So today, to give us a rough outline of what we're going to be doing in terms of sheep nutrition, we're going to be talking about feeding requirements. So some feeding requirements of our different stages of livestock production, specifically focusing on our small ruminant friends, some different feeding systems and feeding types. There's a lot of research that's been conducted by Ohio State in regards to sheep work and sheep nutrition. I've selected a couple of studies that we're going to look at quite extensively, but that's not an extensive list, but just a couple of examples. We're going to be talking about grains and forages and how we can utilize those two different feedstuffs with these ruminant species. And then we'll wrap it up with mineral supplementation. One of my mentors throughout my master's and my PhD career has been Dr. Francis Fluharty, a longtime faculty member with Ohio State over 30 years. He's now at the University of Georgia as their department head. But in some of his talks that he's given, he's really put up a really nice set of questions on why we feed livestock. I thought we would review these here as we got started. Why are we feeding these sheep out to finishing or making feeder lambs? Taking feeder lambs to fat lambs, you may be wanting to use the feed that you already have on hand. You may be a grain producer that has some excess grain that may not meet the specs of the market demand in the grain industry, but it's still suitable for livestock feed and livestock production. More income from grass or grain. Perhaps you live down in southeastern Ohio like Christina and myself. We've got a lot of non-tillable ground, but some of the ground is full of forages, the stuff that we have cut out from the tree lines. So we can utilize that ground more efficiently if we're able to raise a high quality protein for you and I to consume through the use of sheep. We could think about using grain more efficiently than grass. That certainly could be the case depending upon the production parameters that we have these animals under. Perhaps you actually like the physical activity of moving fence and cleaning pens. I know Dr. Fluharty once helped me set up for one of my grazing trials, and he walked several miles. I think it was 9 miles in that day as we weed eated and put up electric fencing for our lambs. You may like to produce this high quality demanding food of animal protein, as we've stated before. You enjoy the challenge, and we know that sheep can be quite challenging at times to produce, and certainly love what we do. Through all of Dr. Fluharty's nutrition series and all of his talks, he was always sure to note to all of his students, regardless of if they were undergraduate, graduate, and even producers, he wanted everybody to ensure that they understood the hierarchy of nutrient use, and that's something that I've carried along with me as well. There's, of course, depending upon what type of animal you're raising, for example, this would be a female, right? We've got 6 different parameters that we need to think about in terms of where is this energy going. The first and utmost important one is going to be maintenance. That animal needs to maintain itself. Once that energy demand, nutrient demand has been achieved, we'll move on to development. Development for our neonates, for example, is going to be, internal organs and such. After the development of those systems is complete, they can put that excess energy, if they have it, to growth. We can see that also if it's a female and she's already reproduced, lactation, reproduction, and fattening. So as we think about this, guys, think about what stage of livestock you guys are producing. We need to think about, with our ewe lambs, for example, that we're raising and we breed early. These females are going to be giving birth at 65–70% of their mature body weight. So we still need to provide them with enough energy to grow, but we also need to bypass that parameter and also get to that lactation stage, because they will have a lamb or 2 or 3 with them, and we need to ensure that we're also providing nutrition to those young lambs as well. And then if you're thinking about finishing some animals, we certainly don't want these animals to be extremely fat, but we don't want to feed them too little that they're not getting to that fattening stage as well. So 6 parameters here: maintenance, development, growth, lactation, reproduction, fattening, things that we need to remember as we're feeding any stage of livestock. So I thought it would be beneficial for us to go through a couple of definitions of some of the terms that you'll be hearing Christina and I using. And it's some general verbiage that you hear a lot in the livestock feeding industry, but nobody really sits down and talks to us and lets us know what we're really talking about. So the first of which is that we're going to talk about is energy. And all this information that you see on the slide here was derived from the small ruminant NRC from 2007. That's our latest version of our NRC or our nutrition guide for our livestock in the sheep world. So energy is going to be defined as the potential to do work and can be measured only in its transformation from one form to another. If we recall back from any of our science classes that we would have had, either grade school, middle school, high school, college, energy is neither created or destroyed, it just changes forms. So what we are doing is we are going to be taking this feeding it to the animal. It's got a certain amount of energy to it, and we're going to use that energy to produce livestock products for us as the human population to consume. So we do know that energy demands change based upon species. Sheep definitely have a different energy demand than you could say our other ruminant species of goats and cattle. Age is certainly going to play a role in the amount of energy needed. Sex will as well. Climate, if you think about today's climate, kind of wet and rainy, if we don't have structures for our animals to get into, they are going to be under some type of cold stress because the wind's blowing and that water is going to make their fleece and then therefore their skin a bit cooler. Thinking about stage of production, obviously a lactating female is going to have the highest demand for energy. Next would be a gestating female, and then an open female would be our least energy demanding. And then also activity level. Activity level is more associated with some of our performance animals. What I would think about there would be a racehorse and what was needed for them in order to perform at their utmost peak. We also need to remember that energy is primarily produced and can be found in our carbohydrate sources or our starches. So a lot of our grains, right? This isn't to say that energy can't be derived from our proteins and our lipids or fats, but I'm going to say that a majority or primarily most of them are originating from these starch-based sources. Protein is going to be the other biggest factor that we think about and what we hear in the nutrition world of livestock here. Crude protein will be represented by CP, and metabolizable protein is going to be our MP. You hear that feeds are always associated with their protein level, and that's because protein is going to be the most expensive, or one of the most expensive ingredients in our diets. And that's how we're able to, or the feed industry is able to sell their feed products based on the amount of protein or nitrogen or N within that product. So again, back to our crude protein, that's going to be the amount of protein or nitrogen that is going to be in a specific feed itself. However, we need to think about metabolizable protein or crude protein. Now, metabolizable protein, that represents our dietary and our microbial protein that's within the system. And we'll get to that here in just the next few slides. The other thing that we need to remember is that animals are going to be eating on a percent body weight basis or on a dry matter basis. No matter the feed that we're feeding, there is going to be a small percentage of moisture involved. If you're thinking about our grains, they're not 100% dry matter. They've got about 5–10% moisture in them. So as we're feeding these animals and we're looking at some of these values, we need to take into account that our feeds may have some moisture in it and that we need to increase the feed intake or the feed on offer to our animals in order to be fulfilling the needs of those animals themselves. So when we're feeding our ruminant species, we need to understand that we're feeding these microbial populations, or at least for our ruminant species, right? We've got a lot of different microbes within that rumen system. And what we're doing with these feeds is we're actually feeding those microbes. Those microbes are going to be breaking down those feeds, utilizing some of those nutrients, and then we're able to utilize some of those microbes as a nutrition source. So that's what I was talking about in the previous slide, that some of the nutrition is received from the feed source itself, and the other is going to be from that microbial population. We also need to understand that there's going to be the production of these VFAs, or our volatile fatty acids. Now, those ratios are going to differentiate depending upon the different feed sources that we're providing these animals. It's definitely going to be different for a grain-based diet compared to a forage-based diet as well. And we can take a look at that here in the next slide. Now, this is, as you saw in the previous slide, is taken from some data from some feedlot cattle from 1970 paper from Anderson and Armstrong, but it applies just quite well to our sheep and our goats as well. So you can see that we've got a forage to concentrate ratio, right? So our forages are going to be the first number in this first column here compared to our concentrates. These are our three primary volatile fatty acids are being produced in the rumen through the breakdown of these feedstuffs: acetate, propionate, and butyrate. You can see as we've got a 100% forage diet, our greatest VFA being produced is going to be our acetate. Actually, as you look down through this entire list, regardless of what the ratio is in the diet, we will always see that our highest volatile fatty acid being produced is going to be acetate. You'll also notice that butyrate does not change much. It goes from about an 8 to an 8.8. Or a 10.8, so we don't see much of a change in butyrate. The two VFAs that we want to focus on are going to be acetate and propionate. And you may be thinking, well, why do we care about what VFAs are being produced? Well, I'll give you a hint here. As you can see with our forage-based diet, 71% of that is going to be acetate that's being produced. But if we go into a diet that's 20% forage, 80% concentrate, probably a very heavy feedlot diet, you can see that that VFA of acetate being produced goes from a 71.5% down to about a 53.5%. In comparison, we can see that propionate goes from a 16% down to a 30.5%. So why is this important? Acetate is a VFA that is known to contribute to milk fat or milk fat synthesis. And that's really nice to know because this may illustrate some diets that we need to be feeding to some of our lactating animals. We know that our young, when they're born, they have a very small intake just due to the physical capacity of their gut. So a lamb can only eat a very small amount in small meals. Therefore, we don't need a great portion of milk being produced. However, we need that milk that's being produced by those ewes and by those females to be extremely nutrient dense. So when we're lambing our ewes, we can feed them a diet that is high in forages itself. We'll have a high level of acetate production being produced, and we'll have a higher level of fat being deposited into that milk source itself. Therefore, fat being an energy source, more energy to that lamb. As that lamb grows, its intake will increase, and we will need to have more milk being produced. So if we're wanting to increase the volume or the amount of milk being produced by these females, we would increase the levels of propionate. And we can easily do that by increasing the amount of corn that we're feeding to those females. So a nice little piece of advice that we can do when we're thinking about what our diet should be for our different stages of livestock production. Some other terms that you're going to hear Christina and I talk about are those most commonly associated with forages. The first of which is going to be TDN, or total digestible nutrients. These nutrients are the digestible carbohydrates, that crude protein, and that crude fat within a diet that we're going to be feeding or within a feed stuff that we have on offer to our animals. We have ADF, which is our acid detergent fiber. This represents our indigestible portions of forages. Those are going to include cellulose. Now, cellulose is that structural assembly of glucose particles that are going to make up that plant cell wall. Now, these are resistant to break down in the rumen. So this isn't to say that we cannot break these down, but it takes a long time, and it's an inefficient process to get these cellulose particles to break down. Imagine that waxy outer coat of that forage leaflet, forage blade that's out in your field. That's where that cellulose, those structural components are coming from. On the other hand, lignin, it's very similar to cellulose, but this is a product that cannot be broken down in the raising animals. So intolerant, and this is a feedstuff that is completely indigestible. Our NDF is going to be our neutral detergent fiber. So this is going to describe the structural components of the plant, right? This is going to include hemicellulose, cellulose, and lignin. So the difference between ADF and NDF is that our NDF is going to have the inclusion of this hemicellulose. In general, as levels of NDF increase, they're going to increase as the plant matures itself. So an older stand of forage is going to have an increased level of NDF. And we also use NDF to describe the actual bulk capacity or the fill of our diet. So as this bulkiness of our diet or NDF increases, it's going to negatively affect our feed intake, which is going to represent our decreases in feed intake. So hay samples, for example, and we'll give those here in a bit, that have high NDF levels are going to result in a low feed intake. So, you know, these high NDF feeds, we're going to add bulk or gut fill to these animals, and they're not going to get a lot of nutrition out of these feed sources. As you can see, that last bullet point, too much of high NDF feeds is a bad thing, but too little can also cause some issues that we'll talk about here in a bit as well. And you can see our definition of hemicellulose down here with those carbohydrates being less complex than cellulose, and they're easier to break down. So thinking, you know, having understanding of, all right, how to utilize these feed sources, thinking about some of the terms that we'll be hearing, let's think about some of these finishing systems that are available to us. We've got two of them that we can utilize pretty easily here in the sheep industry, feedlot and pasture, or a combination of two, but we'll stick to just feedlot and pasture. On the feedlot side of things, we've got several advantages, right? We can capitalize on animal efficiency, so converting some of those grain sources that have a lot of carbohydrates to them that are readily available, easily available, and adding those to efficient gain. If animals are inside in a barn, and this is a nice picture of some feedlot lambs at our research facility up in Worcester at the OARDC sheep unit, you can see that we can control a lot of aspects. They've got a nice automatic waterer behind them. We can control and monitor water intake. We know how much feed goes in. We know how much feed comes out of those feed bunks on a daily basis. What you can't see is all the ventilation and the fans that are provided in that barn. So we keep a consistent environment for these animals to live in. And then also we can decrease the days on feed in some cases. Some disadvantages is that there's certainly a capital investment required in terms of facilities, resources, and how you're going to manage that manure, because it's going to have to be handled by you as the producer and spread back out onto that field. And then, do you have space? Do you actually have the land mass space available to spread those nutrients? On the pasture side of things, there's several advantages to using a pasture-based system. Again, you're utilizing that land pretty efficiently. That can't be used for row crops, but you're still providing a nice, high-quality protein to consumers. There's some niche market access out there that are receiving a premium for the demands of grass-fed lamb. And in some of our research, you'll see that there are leaner carcasses being developed by pasture-based systems when you compare them to our feedlot systems. So, you know, taking a lot of that fat that's wasted, we don't have any value or use for that lamb fat once it's trimmed off the carcass. However, there are disadvantages to the system as well. Parasites being the biggest one. We aren't in a parasite talk today, but that's the basis of my research. And there's a lot of issues going on in the small ruminant world, but also some transitioning into the cattle world that were having a more difficult time managing these parasites themselves. Do you have the resources in terms of fencing, perhaps guardian animals from predators? And we also got to think about environmental effects. Right now we've got plenty of rain, but will this rain sustain the growth of these pastures that you're going to be grazing? So I'm going to go into 2 research projects here before we turn it over to Christine. And these are some research projects, again, conducted at OARDC Sheep Unit in Worcester with Ohio State. So the first of which I wanted to point out here is the effects of fertilized lambs. So to give you a brief overview of this project itself that was conducted by Jabork and colleagues in 2017, there were 3 treatment groups. Treatment number 1 was ad libitum access to whole-shelled corn. Whole-shelled corn will be represented in the graphs or the tables that I'm going to present as WSC. Treatment 2 is ad libitum access to alfalfa pellets, and those alfalfa pellets will be represented by the acronym of ALF. And then treatment 3 is limit-fed whole-shelled corn. Treatment 3 lambs, that limit feeding was based upon the ad libitum intake of the treatment number 1, and those lambs were limit fed at about 80% of the intake that was given to treatment 1. As you can see, it was like, yes, it's 85, my apologies. So there you can see what our diets are composed of in our diet sections for diets 1, 2, and 3. And again, this limit-fed diet group was at 85 ad libitum of the ad libitum diet. So for example, we'll just use an easy number. If this treatment group 1 was being fed 10 pounds of this whole-shelled corn diet, that means that this limit-fed group is only receiving 8.5 pounds of that whole-shelled corn diet that's labeled up here. And again, these diets were adjusted every 2 weeks to account for the adjusted intakes of these growing animals. Here's a nice table that illustrates the growth and performance of the finishing lambs themselves. Off to the left-hand side, we've got our items: initial body weight, final body weight, average daily gain, dry matter intake, days on feed, so the number of days that these lambs were in the feedlot consuming feed. This ratio is our gain to feed, so how many pounds of feed was required to get a pound of gain. And this was our feed cost per gain. So how much did it cost in feed to gain 1 pound of body weight? And again, our groups are across the top: ad libitum whole-shelled corn, ad libitum alfalfa pellets, and limit-fed whole-shelled corn. The piece I really wanted to highlight, guys, was the days on feed, gain to feed ratio, and that cost per gain of feed. As we take a look at days on feed, it should come to no surprise to us that those lambs that were on this ad libitum whole-shelled corn diet grew a lot faster compared to our forage-based diet and then this limited diet. They finished about 87.5 days in the feedlot. As you can see here, those that were on this forage diet or this limit-fed whole-shell corn diet actually had no difference because of their superscripts in the days that they finished. So about 110, 105 days of age is when those guys finished. If you take a look at the gain to feed ratio, so you can see what the amount of feed required to get that accomplished. You can see that the lowest ratio that we have was here on these ad libitum alfalfa pellet fed lambs. But the gain to feed ratio here, so again, pounds of gain to pounds of feed, was quite similar here in our animals that were provided a whole-shelled corn-based diet. For our costs that were required, so a pound of gain, what did that cost in feed? Take a look at this one here. Those lambs that were on that alfalfa pellet-based diet, $2.10 for every pound of gain those lambs gained. That's quite significant when you compare it to our whole-shelled corn diets. Actually, those lambs that were given free access to whole-shelled corn had the lowest cost of gain, less than 50 cents a day. Really nice gains there. Effects of energy source for these feedlot diets, again, taking a look at carcass characteristics of these feedlot lambs. So thinking about them after they've gone to the harvest facility. Same project, and this is all set up in the same manner as well. Take a look at here. We've got our final body weight, our hot carcass weight, our dressing percentage, Back fat's going to be measured in inches. Loin eye area is going to be measured in our inches too. And then this is boneless cut, trimmed retail cuts. So here we can see there wasn't, I wouldn't say much difference with our carcass weight. In general, our lambs that were fed our alfalfa diets had a lighter carcass. We will attribute this because they had a heavier GI tract, because it's been shown that animals that are fed forage-based diets have a heavier digestive tract itself. So that's where that's coming into play. They may have, and as you can see, they weighed the same when they came off trial. There's no statistical difference here. You can also see that they also have a smaller dressing percentage. Take a look at this. Although not statistically different between the two corn diets, those that were on that ad libitum diet have a slightly heavier or higher dressing percentage. And that's probably attributed to them, you know, having slightly more fat. Again, not significantly different though between those two groups there. And then thinking about placing value on these animals, this is boneless, again, boneless or closely trimmed retail cuts. So thinking about the amount of product that we're able to sell in the supermarket to our consumers, and this is what we base a lot of the value off of each carcass of our lamb. Overall, we didn't see a difference in that percentage of cutout. And actually, those lambs that were on that alfalfa diet or that forage-based diet had more of that carcass being able to be sold in the retail market as compared to these whole-shelled corn lambs. I'll attribute that to these whole-shelled corn-fed lambs having more back fat associated with those carcasses. The other of research comes from Ohio State there in 1999, and it's something that a lot of producers still haven't grasped upon, and it's something that I find to be really interesting that's been out for over 20 years here, but it's talking about corn processing and fiber source, and thinking about where can we save some money in terms of making feed and providing different feed sources to our animals. So we've got two different kind of projects going on here. We won't get into the nitty-gritty details of the statistical analysis, but for our main effect of corn type, we've got two treatments. Treatment one is going to be ground corn, and treatment two is going to be whole-shelled corn. And then for our second main effect, we were comparing fiber sources. In treatment one, there was no fiber source being provided in that diet. In treatment two, we had soybean hulls being provided as our fiber source. And then in treatment three, we had peanut hulls being our fiber source itself. So again, we've got all of our items off to the left-hand side. We're just going to be focusing on this first main effect of ground corn, GC, and whole-shelled corn. So this is just whole-shelled corn right from the cob. We've got our initial body weight when we started, dry matter intake, average daily gain, gain to feed, days on feed, and final weight. The only statistical difference that we find here is our average daily gain in terms of our comparison between our two different corn types. As you can see here, guys, is that the average daily gain, so the amount of weight they gained on a daily basis, was higher for our whole-shelled corn diet. So this data itself shows that, you know, in terms of dry matter intake, gain to feed, days on feed, final body weight, there was no difference between these two corn sources. Where we did see the difference was here at this average daily gain. So you could save some money by not processing your corn, because that does cost some money, whether you're doing it yourself on your farm with a mill and cracking the corn, or you're getting it done by the feed mill. There is a cost differential here. So the cheaper option is going to be that whole-shelled corn. And this data shows that it is beneficial to just leave it whole-shelled and let those animals work that rumination. The next piece of the puzzle I wanted to show was comparing these fiber sources here and these fiber sources itself. And you can see that in terms of fiber sources, dry matter intake, when we didn't provide any type of fiber source, they had a slightly lower dry matter intake itself. You take a look at this, there was, if you did provide fiber to them, they finished at, you know, a slightly younger day of age. It is significantly different, but, you know, in terms of actual dates being provided here, only about 4, 5, 6 days difference here. And then our average daily gain was actually improved when we provided some type of fiber source. So again, here, this illustrates that you may not be wanting to provide some type of fiber source, whether the hay may not work in your feeding system for these small ruminants or the feedlot that you have set up. But here, this data shows you can use a soybean hull, you can use that in a pellet form, and you can actually improve average daily gain as well, utilizing these different fiber sources, because these animals are ruminants and they need to have some type of fiber for that rumen to function efficiently and effectively. So with that, we're going to turn this over to Christine.
Thank you, Brady. So hopefully everybody is able to hear me at this point. It's a bit windy here in Cumberland, but hopefully we'll hold out. So far we have talked a lot about fiber in these feeds. And everyone on the call should know that sheep are ruminant animals. They are designed to break down fibrous feeds, but we have different kinds of fibers, and the way those fibers accumulate in our feeds are different. So the section of this presentation that I'm going to cover has a lot more to do with what you do as a manager than the feed itself. So we want to look at what we're providing to the animals as forage and how you as a manager can get that fiber accumulation at a desirable level where you're getting the benefits of the fiber, but you also don't have too much that it overwhelms the system. So this brings up one of the questions that a lot of people have, which is, can sheep be maintained on grass pasture alone? And as almost every topic goes that we answer in extension, the answer is it depends. Sure, you can. Can you do it in every system? No. So there are many factors that go into this decision. We do need to make sure that all the way throughout the year on a grass pasture, our protein content is sufficient to meet the requirements of our animals. We need to provide enough energy that it keeps the animal going every day to perform normal activity. And then as energy demands increase throughout life, it's able to keep up. So we need adequate total digestible nutrient levels. And the way that we can gauge if these levels are going to be on track for us all comes back to forage maturity. The number one factor that influences forage quality is forage maturity. In the picture here on the slide, what you see is a mixed stand of warm season perennial grasses and also some perennial cool season legumes. This is a pretty diverse mix of forages grown on an AEP site here in Noble County that this farmer, Jim Music, has been using to feed cattle. You could also use this type of a mix to feed sheep. So in a system that uses multiple types of forage, you can accomplish this in a perennial system. Moving on to the next slide. We do know that sheep and most animals prefer a diverse mix of different types of forages. This allows for preferential grazing, and we know that sheep prefer short, tender forages. They are selective grazers. So they're going to go through the forage stand and pick out those things that they like the best. They'll graze them pretty short to the ground, and then they'll move on to other things. But they'll continue to come back to that one thing that they really liked. When we give them a more diverse mixture, it improves how they're going to move throughout the pasture. However, the documentable benefit of having more than 3 species mixes in the same pasture is minimal. So we know that there are benefits to having a diverse mix, but when we get too diverse, what we see is those non-dominant forages tend to fall out of the running. The less competitive tend to not be present after a few years. And there's multiple reasons why that would be. They may be less competitive in general with the other plants growing, or they could be the favorite and they continue to be overgrazed time and time again to the point that they're no longer viable in the system. So diversification is good, but also if we get carried away with putting too many things in the mix, we may be disappointed down the road because they won't be there for the long term. When it comes to how we choose to manage our systems, there's things we want to keep in mind when we look at the forages available to us to grow in Ohio. We can essentially break those into two categories, which are our cool season forages and our warm season forages. When you classify those, you can think of our cool seasons that prefer a temperate climate. In our warm season forages, you can classify those as preferring a more tropical climate. If you look at the graph on the bottom of this slide, what you see is the forage growth curve. The lighter green color shows the peaks and valleys of the cool season grass cycle throughout the year. They like to grow when the temperature is between 65 and 75 degrees. So we get most of our growth on these forages in the spring. And once it gets hot in the summer, they tend to go dormant. And this has to do with the respiration process and trying to allocate resources to make it through for the next growth cycle. So they tend to go dormant during that mid-summer when it's very hot and tends to get more dry. It hasn't always been the pattern, but often in August are pretty dry. And then we see a ramp up of growth again in the fall. We can use that fall ramp up of growth to our advantage as well in a grazing system. What do we do about that middle spot where we have summer slump? That can be filled with warm season grasses because these grasses prefer hot and drier conditions. If moisture is available, they will use it. But the way that they perform photosynthesis actually allows them to keep growing in drier conditions than most of our do. There are many options that you can use to incorporate warm season forages into your systems, whether that's perennial forages or annuals, tall growing, short growing, for grazing or for hay. The reason that these plants do better during that hot period of time is because they are more efficient at performing photosynthesis. When we move on to the next slide, I have a little bit of a lag on my end, guys, so thanks for bearing with me. What we see here is that the point at which we get our best quality of forage is not the same point where we get maximum yield. And that is true for both our warm seasons, our cool seasons, our annuals, and our perennials. Also true for our winter growing forages as well. So what we want to do is try to harvest or graze our forages at the point where both of those things intersect, where quality is high and yield so. We want to be right there in the sweet spot in the middle before those plants turn reproductive. But also we want those plants to have enough growth on them that when we remove the leaf stress, the root system. So what is more important to you as a manager? Having quality feed or having a lot of feed? And when you think about that, what good is it really to have a plethora of poor quality forage, whether that's overgrown grass out in the pasture because our stocking density was too low, or super short forage that's hardly there to eat because our stocking rate was too high, or hay that's harvested too late, or hay that's harvested too short. There are many things that affect that, and we want to make sure we're hitting that good zone. We've talked a bit already, which is that as grass quality changes as plants mature. So as the plant matures, our fiber content increases, our protein content decreases, and our digestibility decreases. So what you can see in this chart is just a comparison of a few different species and how it changes as time goes on. This is a average of a few different grains. But you can see in the vegetative stage, our crude protein is the highest, our ADF is the lowest, our NDF is the lowest, and our relative feed value, RFV, is the highest in the vegetative stage. So what affects our dry matter intake altogether? We've talked about that maturity aspect is what's going to make our fiber accumulation go up. Well, what does that mean when it comes to terms of animal intake? When our fiber is high, our forage is less palatable for the animal, and it's less digestible. So they can't eat as much, they won't gain as much weight, and they won't be as enthusiastic to eat because it doesn't. When we have overmature forages, we have increased lignin. And you can see in this electron micrograph scan of an alfalfa stem, this shows you after 48 hours incubated with rumen fluid that tissue that remains, those are the lignified cells of them. They're still hanging out. Much of the stem will be able to be digested, but much of it will not. And the older that forage is, the less of it that will be digested. And when we see overly mature forages, we tend to see more instances of hay belly, which is where our animals they have been eating forages, but they're not adequately digesting it. We're getting a backup or a buildup of fiber in the system. So you can actually have animals that are losing weight or losing body condition, even though it seems that they're full and they are eating. So getting that balance of fiber is very important. Brady, feel free to chime in here if you have more you want to add with those micrograph scans. When we look at the plant cells inside the leaf tissue, this is what you would see in a cross section, looking at a C3 plant and a C4. Again, C3 is cool season, C4 is warm season. The basic plant structures that you see in these charts are the epidermis, which is like the skin. This would be equivalent to our skin on a plant. This is a one-cell layer that protects the outside of the plant. It's often coated in a layer of wax. The mesophyll, you can think of this kind of like the muscle of our bodies. This is the tissue that has large, thin-walled cells. This is where most of our digestible carbohydrates are. This fills a lot of the space between the upper and the lower epidermis, so the top skin and the bottom skin. Then we have the sclerenchyma tissue. This is the tissue that supports the vascular bundles. It is heavily lignified, but not as lignified as the tissue actually inside the vascular bundles. So you can think of the sclerenchyma as like the tendons that hold your muscles together and help keep the muscle on the bone. And then you can think of those vascular bundles like the bones of the plant. These are heavily lignified, and they contain the xylem and the phloem cells. That's the transport system of water and nutrients throughout the plants. They're surrounded by 1 to 2 layers of cells, which are known as the bundle sheath. That's the inner workings of the leaf. You can see here some more micrograph scans that show you the digestibility of tall fescue. And we're going to see on the next slide a comparison to Bermuda grass. So tall fescue is a cool season plant. Something that you can see from these micrograph scans is that forages actually digest from the inside out, and you can see after increased time in the rumen, you can see how that digestibility breaks down. I'm sorry, I'm getting notifications here that were distracting me. Go ahead and move on to the next. And then we see our leaf tissue digestibility in Bermuda grass. Significantly different. We can see a lot of that plant tissue is still remaining after 72 hours when you compare it to what we saw with the tall fescue. It's really interesting to see. We know that this is happening, but to see it on a close-up scale is really intriguing, at least it is to me. Then when we talk about forage processing, this is when it comes down to what you as a manager do to get the best forage harvested as possible for your animals. So whether you're choosing to harvest that by grazing or harvest it mechanically as hay or baleage, these are the things that are occurring in the environment that will affect the quality of your forage. We've got the sunshine. These are in order of importance. Our relative humidity in the atmosphere, our air temperature, the wind, and also the moisture of the soil. When any of those things are out of whack, we have issues with harvesting good quality forage. And we could talk for a long, long time about forage processing, but this is a nutrition talk, not a hay talk. So I'll keep it short. When we look at the management factors that affect our drying rate, we want to think about cutting those forages as early in the day as possible so that they have maximum exposure to the sun to dry out. If you have issues with drying out crops, you can mechanically condition them, which is going to basically break open the stems and allow that water to dissipate. But that's not something we want to do with legumes because it increases shattering, but it works for grasses. We want to spread in wider swaths. That's going to improve drying. Rake when the dry matter is between 50 and 60%. And then you can also consider chemical conditioning if that's an option with your equipment, and that's going to improve your drying. And then we want to make sure that when we're baling our forages that we're getting it at the right moisture so that one, we don't have a risk of mold, and two, we don't have a risk of fire as well if you're storing these inside. And the correct dry matter for our small rectangular bales is 20%. When you get bigger to the large round bales, we're at 18%, and our large rectangular bales at 16% moisture. If we get that dry matter too wet, we increase our chance for spoilage. And if we get it too dry, we lose quite a bit to shattering. And then we've talked a lot lately about the options of doing wet wrapped forages, often called baleage. The ideal moisture to get this done and get it done right is to bale and wrap those forages when they're 45 to 60% moisture. And that's actually pretty wet. So a lot of people think that they can do this the next day and it will still be wet enough, but they actually tend to get out of that zone. You want to bale and wrap these on the same day as you've cut them. Getting a dense bale is critical because if we have too much air in that bale, we're going to have issues with spoilage. To get a good wrap on these, we need to wrap at least 6 times. It does depend on the thickness of your plastic, but 6 times is the general recommendation. And then when you feed these types of forages, we want to make sure that we're providing an appropriate amount so that it's consumed quickly. That's going to reduce the chances that you'll have spoilage while the forage is sitting in the feed bunk. All of these things are part art and part science and will take practice to get right, but are all extremely important in getting those fiber concentrations correct for your animals at their stage of life. And with that, Brady, back to you.
Thanks, Christine. Christine's talked heavily about the use of forages, and we'll continue on that track as well. But what's important is that regardless of the type of forage that you're feeding, whether it's a dry hay that's been made, whether it's a baleage or wrap bale, sweet hay, or even silage, or even that hay or grass or forage that's standing out in your field, it's important to get a nutrient analysis, a forage analysis on this, to have an understanding of what you are feeding at the current time. With a lot of our research, we actually go out and we handpick some forages just as if we were sheep grazing throughout the field, and we're able to get real-time, real-life data on what the quality of that feed is on a given date. This is an example of what a feed test or forage nutrient analysis is going to look like. This was submitted by the folks at Fairfield OSU Extension for a producer. You're able to get this done pretty cheaply through Extension. It's definitely worth dividends in itself to get these forage analyses done and conducted. I encourage you also to reach out with your local feed mills or even your feed representatives and see if they're able to get your forages tested as well, because some companies do offer that. Here, I just wanted to run through of what this looked like. We've got moisture, as Christine was talking about, and and conversely, we've got our dry matter. So if you take the difference between or you take those and add them together, you get 100%. So this feed source, or this hay that was collected, and it was collected on the 12th of July there. You can see this was a mixed first cut hay, 4th of July hay in my opinion, so probably some old rank hay that was made. You can see that crude protein was 6%. You saw on Christine's previous slide that in order for us to have proper rumen functioning, we have to have a crude protein of at least 7%. If not, we can't even sustain a microbial population with that in that individual. So in this case of this feed source, this doesn't even provide the minimal amount of nitrogen required to sustain life within that animal. The one thing I did want to point out is a lot of people like to take a look at these net energy requirements. This is going to be net energy of lactation, maintenance, and gain. Unless you have told the people that you are submitting this information to that this is going to be fed by sheep, a lot of times these formulas are going to be derived from the beef and or dairy NRC. So a lot of these values are going to be based upon feeding values, giving it to cattle of the dairy or beef varieties. So therefore, these really don't apply to what we're trying to do with sheep. However, it's nice to know what the dry matter is, what your crude protein is, and also what your TDN is, or the percentage of that feed that you're going to be feeding that's going to be utilized. So for example, this one will say 34% to round it, to make it easy. So imagine if this bale was 1,000 pounds. That means that only 340 pounds of that bale is going to be able to be utilized by the animal that you're feeding it to. So therefore, 2/3 of that bale of hay is going to be wasted. So this is why it's critically important to, one, manage your forages as appropriately as possible, and two, to get a forage analysis done. This is an example of a brassica field, and this was collected on the 8th of November in 2017. This was a set of purple top turnips at my land for grazing. And this was a live forage standing out in the field, but I just wanted to take a look at just some of the vast differences, guys. Crude protein, 23%. This was, again, the 11th of November. This feed source was standing out in the field. Take a look at this, TDN value, 73%. 73% of that feed was going to be utilized that was being consumed by that lamb. So extremely different compared to that hay sample that we just took a look at. So I wanted to really interesting information to provide. At the end of the presentation, Christine can provide the link to our video that is on YouTube that we submitted for a forage focus. And what we did is we broke down these different types of forages, the top of which here is our brassicas, or our purple top turnips. Oats, we had oats that we were grazing as well. And then we had actually stockpiled tall fescue that was just out in the field. It was fertilized in autumn, and it was not grazed until November there. And across the table here, we can see the crude proteins that were available. We can see that the crude protein of the tall fescue here is at 11%. But this was in the middle of December, so that's quite, it's actually a nice feed stuff still, given the fact of what that is. You can take a look at our NDF values, and you can kind of see that these are all on point. We don't have a problem with these. The only NDF values that I actually have are here with this 29 and 30 coming from our brassicas. Now, we said that low NDF values could be a problem as well earlier. If we don't have a lot of bulk density in that diet or fiber sources in there, it's going to increase the passage rate of our feed source. So therefore, the retention rate of this feed or this brassica is going to be quite quick, and that might result in loose manure, loose stool. So one way that we can correct for that is that we could provide that hay I just previously showed you that was high in fiber, low in protein, low in feed value, provide a little bit of that as fiber, and we can slow the passage rate of that fiber or this feed source here, and then therefore our animals could better utilize this feed source. What we also thought would be interesting is to show you some of the values that are pulled from this small ruminant NRC. So what I've done is I've taken this example, and in this example with all of these figures that you're about to see, is that we calculated the TDN, or total digestible nutrient requirements, for a 154-pound ewe. So a nice commercial white-faced ewe, probably you would see here in the eastern US. So we took it during their different classifications or stage of production. This one's going to be in maintenance. Her estimated intake is going to be on a percentage of body weight, but what I've done is I've taken this body weight of 154, I've multiplied it by the estimated intake percentage-wise, and we've got this ewe that's in maintenance at 154 pound, requires about 2.5 pounds of feed. She's going to require 1.36 pounds of total digestible nutrients. And then what we've also done is we've taken, all right, we went back to this table, we've taken the TDN values of this, so this means that 73% of every pound of this feed that's being fed will be utilized. We've done our math according to the intake that's going to be occurring with this individual, and we've got these values. We've done the same with early gestation. You can see with early gestation whether they have singles, twins, or triplets. Of course, as the number of fetuses increase, the amount of intake required will increase, as well as the required TDN. And we've also done this for late gestation, again, with multiple fetuses. I know we're going a bit quick here, but for the sake of time, we'll kind of go through this. And if you guys need more time to digest it, these slides in this presentation will be uploaded at the end of this, and you guys can come back to review it. But this is a nice summary, again, of this same animal, whether she's in maintenance, early or late gestation, based upon the amount of fetuses that she had. And we took the TDN values of those feed sources, brassicas, oats, and stockpiled pasture, on the 11th of November, or on the 8th of November, and you can see all of our values are in green, which means we're in the good, because our total TDN requirements by those females are all met by grazing on that standing feedstuffs, which I find to be pretty incredible that even with some of our stockpiled pasture that was a bit lower in value, we're still able to sustain those females and also those growing fetuses. However, as we transition into mid-December, so we were at the 13th of December here, for our brassica group, actually we're all good still in terms of total digestible nutrients. But as we go to late gestation with females that are 154 pounds that have twins and triplets, we see we're in the red here with our oats and our stockpiled pasture. We just don't have enough feed out in them pastures during this time period. But nonetheless, we can still utilize these feed sources and provide supplemental protein and energy to these females and still get along quite all right. The last piece of the puzzle we kind of wanted to briefly overview was mineral supplementation. And I think this is a really important topic that sometimes gets overlooked when we're talking about small ruminants specifically. Minerals should always be available to our livestock. You can see why I believe it's important. I've given 3 examples of zinc, selenium, and copper. A lot of those are involved in the basis of just life with immunity, growth, the formation of different types of systems. And what I briefly want to review is mineral interactions, the bioavailability of these minerals, and how is this mineral being provided. A lot of times producers will say, hey, you know, I've got my mineral feeders sitting out there, but as long as these do not have mineral in these, this is not considered an appropriate mineral program. We always got to ensure, just as we're feeding or checking water on a daily basis, we should be checking these mineral feeders on a daily basis as well. Thinking about different mineral interactions, I like this web here that shows the complexity of minerals and how they interact with one another. For example, we know the importance of selenium in sheep, and we can see that selenium has a couple different parts of the web. Selenium can be associated with sulfur. We know that we've got to be cautious with sulfur. Too high levels in sulfur can cause some issues with PEM and some other digestive issues as well. But we also see that sulfur is linked up with copper. Copper is considered to be toxic at high levels with sheep. Sheep actually have a requirement for copper, but it's quite low. So we need to understand that we've got to still have and supply some of these nutrients or some of these minerals to these animals in order for them to fully function. And for us to understand this, I've used this Liebig's law of the minimum. And with this barrel here, this is a really nice example. So for example here, selenium is our shortest rung on our whiskey barrel that we have here. So if we're wanting to fill this barrel up with water, well, this is going to be our weakest point. And we know that we should be supplying supplemental selenium due to the deficiency in our soils in our forages. So as we supply supplemental selenium, the board or plank on this barrel will begin to increase, and therefore we'll be able to hold more water and be able to utilize some more of these minerals more efficiently as well. The other piece of the puzzle that I've gotten from, and then Dr. Fluharty's really shared this with me as well. But we need to understand the form in which these minerals are being provided to our animals and our mixes that we're providing to our livestock. Here you can see we've got the minerals of copper, magnesium, and zinc. The thing that I really wanted to point out here is these organic forms, or these complex or chelated. So this means that these minerals over here in this area or category are going to be associated with an amino acid or a protein. Now those are readily digestible by our animals. For example, if we supply zinc in the sulfate form, we'll get 100% utilization. If we supply zinc in the oxide form, we don't get much. There's a line because there's not enough data here to support that we get any type of zinc oxide form being utilized. But as we transition into feeding a zinc chelate, that might be something that's with a protein, we can see that we can increase the utilization quite a bit, 159 to 206%, simply by putting it into this organic form. It doesn't necessarily mean that it's organic in terms of what you would traditionally think organic represents. It just means that it is associated with a protein itself. I will note that this is going to be a more expensive form of the mineral, but in my opinion, when you're searching for minerals, you pay for what you get. So the more expensive that mineral is, it may be worth the investment because it may be able to be better utilized by the animal itself. And the last part that I wanted to mention here was, how is this mineral being provided? Reagan and colleagues from 2015, although this is salt we're talking about, it was how minerals were going to be provided. What they did is they compared a loose mineral or a loose salt to a block salt. And as you can see here, with our significant differences, those lambs that were consuming loose salt actually consumed twice as much more as compared to the block salt. So when given the choice, animals would prefer to consume a loose mineral, a loose salt, and therefore we see an increased intake. We compared this in one of our studies at Ohio State, one of them that I did during my master's career in 2017. We were comparing lambs out on pasture grazing. They were given the same mineral. Half the lambs were provided that mineral in the loose form. The other half provided the same mineral in a block form. And we can see that at the end of the trial, when comparing block forms or mineral forms, those lambs provided loose mineral, had a heavier body weight at the end, and also had a greater average daily gain while out on pasture. So to wrap up this talk on sheep nutrient management and the nutrition of the basics of sheep nutrition, in general, lambs fed this high concentrate diet perform better when compared to other feed stuffs or forages. However, this does not always have to be the case, and there is supporting evidence out there that shows this. Don't think that you have to feed all of your animals a grain-based diet for them to finish appropriately. The process of feedstuffs can affect lamb performance and feed digestibility. So as we showed earlier, processing of grains isn't necessary for sheep in order for them to perform as well as processed grains. You may be able to cut down on some of your feed costs even doing that as well. Grain-fed versus forage-fed lambs, we need to consider our options. Forage-fed lambs are a bit leaner when it comes to a carcass. We saw that they had more value to them in terms of amount of carcass being produced from a lean meat standpoint, and that's nice. And our grain-fed lambs, they may finish earlier in the feedlot. However, they will produce a bit more fat that's going to be wasted. So those are some things that we need to consider. So, but ultimately this diet that you're going to be feeding these animals will be dependent upon your resources you have available, the market that you're trying to get into, and personal preference, how you would like these animals to be managed and fed themselves. So with that, Christine and I appreciate you guys tuning in, hanging in there with us. And we hope that you guys will join us back at 3 as we go through some health management scenarios regarding ruminants.
Yeah, thank you, Brady, for wrapping that up, and for everybody for listening. If you have additional questions, we know that every system out there is a little bit different and it has unique needs. And while we are not nutritionists and we can't provide you pounds per animal to feed, we can help you walk through some of the things that are unique about your situations. If you need to learn more about grass-fed systems or different types of feeds, we have lots of resources available on the Sheep Team webpage that you can browse yourself, or you can contact us for links.
Okay, thank you so much, you guys. This was great. And if anybody does have a question, feel free to type that in the chat right now. I haven't seen any questions yet, but you guys did a great job. Really appreciate it. And like Brady said, I hope everybody comes back at 3 o'clock and we will continue our sheep bracket. Thanks, everyone.